Designing embedded systems, one of the most critical decisions engineers face is choosing the right communication protocol. Protocols determine how devices talk to each other, share data, and ensure everything works smoothly. But with so many options available, how do you know which protocol is best for your application? In this video, we'll break down the main factors that influence protocol selection in embedded systems, using real-world examples to make things clear. Let's start by understanding what makes each protocol unique and why your choice matters for performance, reliability, and cost. First factor to consider is bandwidth and data rate. This refers to how much data needs to be transferred and how quickly. For example, if your system needs to handle high-speed data like streaming video from a camera, you'll need a protocol that can keep up, such as Ethernet. On the other hand, if your application only sends small amounts of data like sensor readings, simpler protocols like I2C or SPI might be sufficient. Choosing the right protocol ensures your system runs efficiently without unnecessary complexity. Imagine a network of smart security cameras sending live video to a central computer for real-time surveillance. If you tried to use a low-bandwidth protocol like Bluetooth, the system would struggle to keep up with the high data rate required for video. The result? Poor video quality, lag, or even missing frames. That's why high-bandwidth protocols like Ethernet are chosen for such demanding applications, ensuring smooth and reliable video transmission. Another key consideration is power consumption. Many embedded systems run on batteries, so energy efficiency is crucial. Power-hungry protocols like Wi-Fi can quickly drain batteries, making them unsuitable for devices that need to operate for long periods without recharging. Instead, low-power protocols like BLE Bluetooth Low Energy are preferred for wearable devices or portable sensors, helping to extend battery life and reduce the need for frequent charging. Consider a smart wearable health monitor that tracks your activity and sends data to your phone. If it used a high-power protocol like Wi-Fi, you'd be recharging it constantly. By choosing BLE, the device can operate for days or even weeks on a single charge, making it much more practical for everyday use. This example shows why matching protocol power requirements to your application is so important. Range of communication is another crucial factor. Some protocols like Wi-Fi are designed for long-range communication and can connect devices spread across large areas. Others, such as Bluetooth, are intended for short-range connections. Selecting a protocol with the right range ensures that all parts of your system can communicate reliably, whether they're in the same room or spread across a building or even a farm. Smart home automation, protocols like Zigbee are often used because they're optimized for low-power, short-range communication between devices like lights and sensors. But for outdoor applications such as smart farming, you might need a protocol like LoRa, which can cover much greater distances. The right choice depends on the physical layout and communication needs of your system. Some embedded systems, reliability is non-negotiable. In environments with lots of electrical noise or where safety is critical, you need a protocol that can guarantee data integrity. Protocols like CAN Controller Area Network are specifically designed for high dependability, making them ideal for automotive systems or industrial settings where communication errors could have serious consequences. Think about automotive safety systems like those controlling brakes or airbags. If a less reliable protocol were used, communication failures could lead to system malfunctions, putting lives at risk. That's why robust protocols like CAN are standard in these applications, ensuring that critical messages get through even in harsh conditions. Cost and complexity are always important considerations, especially for resource-constrained devices. Some protocols require expensive hardware or complex software stacks, which can drive up both the price and the size of your system. For simple applications, it often makes sense to choose a straightforward protocol that meets your needs without unnecessary overhead. For a basic home automation system where devices just need to send or receive simple commands, using a complex protocol like Ethernet would be overkill. Instead, protocols like I2C or UART are more suitable. They're easy to implement, cost-effective, and get the job done without adding unnecessary complexity. This approach helps keep your project affordable and manageable. Choosing the right protocol is all about balancing your system's needs. You have to consider bandwidth, power, range, reliability, cost, and complexity. Often there's no perfect solution, just the best fit for your specific requirements. By understanding these trade-offs, you can make informed decisions that lead to efficient, reliable, and cost-effective embedded systems. Let's quickly review some of the most common protocols used in embedded systems. Ethernet is great for high-speed, high-bandwidth needs. Wi-Fi offers wireless connectivity over longer distances, but uses more power. Bluetooth and BLE are ideal for short-range, low-power applications. I2C and SPI are simple, low-cost options for connecting sensors and peripherals. CAN is the go-to for reliability in noisy or safety-critical environments. Each has its strengths and weaknesses. When it's time to make your final protocol selection, revisit your system's requirements. Think about where it will be used, how much data it needs to handle, how long it should run on a battery, and what your budget allows. Test different options if possible, and don't be afraid to consult with experts or review similar projects for guidance. The right protocol can make all the difference in your system's success. Wrap up: protocol selection in embedded systems is a multifaceted decision that impacts performance, reliability, and cost. By carefully considering bandwidth, power, range, reliability, and complexity, you can choose a protocol that fits your application perfectly. Remember, there's no one-size-fits-all answer. Each project is unique. Thanks for watching, and we hope you now feel more confident about choosing protocols for your next embedded system design.